So now I'm going to discuss enzymes with you. Enzymes are basically what happens to form catalysts inside your body. And so just like a catalyst, enzymes speed up the reaction that is happening within your body. So if you want to consider this, we have reactants and we have products. And remember, you have to go across the transition state, or you have to put in energy to make a reaction happen and give you products. Well, without an enzyme, that transition state could be a higher level of energy. With an enzyme or a catalyst, however, that energy is lowered, and so it's easier to get the products for a given reaction. These are basically, when made in the body, enzymes. They're basically a protein, or a vast majority of them are proteins, and then they have in their center an active site. Now, that active site's where the catalyst action takes place, or where the enzymatic action takes place. And that active site often even has a metal inside of it, some of which we understand and some of which we're still trying to research. But these enzymes basically take a reactant that we call a substrate when it's in the body and form a product of some sort. So enzymes, we tend to say, bind or come together with substrates, which is kind of like the body's reactants. The enzymes come into the active sites with, and that's what binds to that substrate. So a way to look at this catalytic cycle or enzymatic cycle as we look at it within the body, first it begins by the enzyme and the substrate coming together. They form what we call the ES complex. So the enzyme substrate complex. So in other words, something happens in that active site where you've got the substrate and you've got the enzyme and they come together and something changes. Maybe there's an exchange of something, or maybe there's a removal of some part of it, or maybe the whole thing just gets pulled apart. There's a lot of different types of enzymatic reactions. That substrate or substrates, it could be more than one, then form a product. So that's referred to as the enzyme product complex or EP complex. And finally, when those two things go apart, the enzyme and the product will separate. Now, just like with a catalyst, the enzyme is not used up, and so it then repeats its reaction again, which means that you really only need a very small amount of enzyme to convert a whole bunch of substrates into products. Okay. There are different types of enzyme models. One that we used to think was true is the lock and key model. This was where you have a lock that's very rigid, that would be your active site. And we thought that maybe substrates to go in and can only fit in there because it's the only thing that fits. Well, we know now that may not be the best type of model. Instead, what we find is that the induced fit model is probably more close to accurate. Here, enzymes have a basically flexible active site, and it fits substrates, and it can adapt as that substrate comes in to land in the active site. So in this way, both the enzyme and the substrate kind of work together for that reaction to take place, or better yet, for the substrate to fit into the active site. Okay, there's some major classes of enzymes, 6 of which I hope that you can know. The first is isomerases. Now remember, isomers are things like cis-trans isomers, things that might be bonded differently and yet have the same number of carbons and hydrogens and nitrogens and whatever it may be. So these can basically enzymatically change something from a cis to a trans, for example, or make different enzymes with that substrate. Next we have transferases. So this can exchange a functional group between two molecules. So say that you have a C double O bond on one of them and you have an alcohol on the other, or say that you just have a methyl group on the other. What can happen here is that C double O bond might go to the first or the second substrate while the methyl group goes to the first one. So it's basically like where things get transferred, hence the name, in transferases, okay? Notice that all of these end in ACE, or ACEs is a class of them because these are enzymes, and enzymes have the last like word is ACEs, it ends in ACEs. Okay, next we have oxoreductases. As you would imagine, these are things that catalyze oxidation and reduction types of reactions. Next we have hydrolases. This is a type of enzyme that aids hydrolysis, or it aids the addition of H2O to a molecule, and that typically splits the molecule in half, like hydrolysis of a peptide bond. And next, these two sound a lot alike, so let's go with this. Lyases, they basically add or remove a simple molecule within the substrate. So this is like adding an H3 or adding CO2, okay? Ligases use ATP energy, adenosine triphosphate energy, and these join two substrate together. So, LIG forms things together, and lyases basically are a special form of where something is forming or what's being put into there. Okay, I hope that made sense. Have a great day.